All right, so for this one, I do x is vxt. I do two-dimensional motion here. And I do this because we're looking for the E field, which we know to be this way. And so then, just like yesterday, I'm saying that some of the forces in the Y are equal to MA. So EQ is equal to MA. So A is EQ over M. So that works for this. The Y becomes 0, so I get VYT. Oh, that's negative, by the way, because that has to go down. VYT is equal to negative 1/2 AT squared. Okay, so then that cancels one of these T's. And then over here, I take this and say T is X over Vx. So then I say Vy is equal to EQ over 2M and then times X over Vx. Oh yeah, and then oh man, I actually got reasonably far yesterday. So Vy is V sine theta. And then that's going to be EQX over 2M V cos theta. So then I get V squared 2 sine theta cos theta M equals EQX. And then I can divide both sides by EQX, or I'm sorry, not by EQX, but just QX. And so I get my equation for E as V squared sine 2 theta over QX. And since theta is 45, sine 2 theta goes away, it becomes 1. So I take my V squared over Q and X.
What's X?
X is 0.04.
0.04 because it's the distance
That's when it went boom and hit over there. So,
do you know what Q is? Oh.
Yeah, Q is 126 times 10 to the minus 19. So this becomes 25 times 10 to the 12, right? So it's 25 times 10 to the 12 on top. And then 1.6 times 10 to the minus 19. Are we ready to take the quiz?
No.
No? Questions, make sure you ask. 1.6 times 10 to the minus 19 times 0.04. Okay, and yeah, so whatever, do that on your calculator. Yeah. I'm sorry? Yeah, well, I believe, unless I made a mistake like yesterday, it says an electron. Ding.
We're supposed to know what the electron is?
Yes. And it's not so much that you have to know it. It's on the inside of your book. It's also in your formula sheet. Well, if you printed out that section, of your formula sheet that has all the constants on it, it's on that page. It tells you. All right. Now, once we've figured out this, right? Well, actually, we can also, actually, do we need it? Yeah, we needed that for this. So the easiest way might be to use this equation, Vf squared equals V0 squared plus 2ax. Or sorry, in that case, it's technically going to be like, I'll just put, this is going to be d, right? And then solve for d. And you know V final squared is going to be 0. You know V0 squared is going to be V sine theta, right? And then A is that. Okay. By the way everyone's staring at me, I say I need to do it. Okay. So Vf is 0. V0 is equal to V sine theta. A is equal to negative EQ over M. And then we're looking for D. So we say D is Vf squared minus V0 squared all over 2A. which of course gives us negative V0. Oh, just kidding. Let me plug everything in. Negative V sine theta over 2EQ, and then put an M up there.
Isn't it negative with long too?
Yeah, it is. Thank you very much. Which will cancel that negative there. And so we get V squared sine squared theta M over 2EQ.
And we know what E is, we know what Q
Yeah.
is. I mean, however,
We know M.
we do?
Yep.
What's that?
Just call it emergency.
Huh?
911. 9.11 times 10 to minus 31. The mass of an electron?
Oh, okay. I was like, wait a second.
That's also on your formula sheet as well.
Oh, it is? Okay, no wonder my dude was Wait, Mr. McClure? So, V0 is basically V sine theta, which is basically the deceleration going up.
Vertical velocity, yes.
Vertical velocity, and then A is what?
A is, we found that from the sum of the forces. What is accelerating this thing downward? It's the electric field. So I did MA equals EQ, negative EQ.
Wait, so how does that, like, what would the force diagram look like? Would we just,
It would just be an arrow pointing down.
that's it? An arrow pointing down?
Yep. Here's the electron, and the sum of the forces is that.
Oh,
And this is FE. So I get sum of the forces is MA. So we get, or so what, negative FE, whatever. Negative FE equals MA, and that gives you this.
because, and FE is always equal to EQ, because,
Well, in this case, FE is equal to EQ, because there's not two charges, there's only a charge in a field.
okay.
So you use EQ.
But then, like, if there's two charges, it would be EQ as well.
Yeah, exactly. All right. Plug this in, what do you get? Yeah. Why is this negative? Because it's pulling down. And we shot the thing up first, so that means up is positive. So because the initial velocity is given as a positive number, we have to say up is positive.
But if you give us, like, a negative number, then like, and, like, the downward
Yeah,
slope is
exactly.
positive.
Okay?
And
So,
then,
yeah. I don't know what those two numbers come out to be, but there you go. That's how you do it.
and then we just applied the two-dimensional